Welcome guys to today's class. In today's video, we want to discuss an important experiment in practical physics, and that is experiment on determination of focal length and nature of images formed by convex lens. Then ensure you write the date of your experiment at the top. Yes. What is the objective? To determine the focal length and nature of images formed by a convex lens. Another name for convex lens is called converging lens. Now, this is the experimental setup, the diagram of it, so to speak. Here you see the work table. Then you see a ray bus carrying the light source. This is the ray bus carrying the light source and carrying the object, so to speak. You see the lens holder carrying the lens itself. Then you see the screen carrying this image of that object inside the ray bus. And you see the meter rule that you will be used to what? Measure your distance, so to speak. And that is just for the diagram. Procedures. It has so many procedures. Procedure 1. Place the lens on the lens holder and use it to project an image of the window or a light source as far as 10 meters or more from the lens on the screen by adjusting the screen until a sharp image of the object is obtained. Measure and record the distance VO of the screen from the lens. Now, this procedure 1 is meant to be conducted in the lab. What is the essence of this procedure 1 is for you to be able to get the actual focal length of the convex lens given to you. Yes, but because we are performing this experiment without touching apparatus, you need to ask yourself, do I know the focal length of the lens that is available in that lab? Yes, every lab has the focal length it make use of. Like the lab we have here has the focal length of the lens we are making use of. Yes, every lab has the focal length of the lens it make use of. Are you get what I'm saying? Now, the essence of you to watch this video is for you to see how you can do this experiment without touching apparatus. Remember that lens formula is 1 over f equals to 1 over u plus 1 over v. Now, from the information, as far as 10 meters or more from the lens, the implication is that u should be at infinity. It does not have a specified distance, so to speak. Your object distance, the distance for that your object do not have a specific what value, and that is why we say put it at what? Infinity. That is what they mean, 10 meters or more. That means if you say 1 over f equals 1 over infinity plus 1 over v, you will be having that 1 over infinity is 0. That means 1 over f will be equal to 1 over v. 1 over f equals to 1 over v. That means your v is equal to your f. Your VO will now be equal to your focal length, and that is this VO we are talking about. Yes, the essence of performing procedure 1 is for you to get your focal length. We approve it from the formula we just wrote here. That is for you to get your focal length. But in this case, we didn't perform this experiment. We are trying to do it without touching what? Any apparatus. And what will help you to do that? Whichever lab you are, or whichever university or secondary school you are, that focal length of your lens, that your school has focal length of the lens they make use of. Yes, they have focal length of the lens they make use of. You are just trying to perform the experiment to what? Confirm it, so to speak. And so try to note the focal length of the lens your school make use of. Yes, very important. If they do not want to tell you, even the past students, the students that are in the next class already, will tell you the focal length they got. It will help you. Now, in case you couldn't get any information, note that focal length of convex lens ranges from what 10 to what 20 cm. It has a wide range depending on the lab you are, or depending on your school, so to speak. 10 to 20 cm. In the lab here, our focal length of our convex lens is f equals to 15 cm. That is the one we are making use of in this lab. In some other lab, they make use of 10 cm. You understand? So try to note the one your school make use of, so to speak. But if your school do not have any focal length, that the specified focal length, so to speak, please use f equal to 15 cm. If you couldn't get information on the focal length of the convex lens your school make use of, please, if you couldn't get the information, use f equal to 15 cm. It is better. Okay, so in this video we will be using f equals to 15 cm as our focal length, and that will be the value of this your VO that you would have gotten when you perform procedure 1. Now procedure 2, place an object, say a broomstick, over the hole of the ray bus and set up the ray bus, lens and screen as shown in the diagram above. You can see the broomstick taken as the object inside this ray bus. Then they say we should set up the ray bus, the lens, and the screen. Then procedure 3, adjust the height of the lens, object, and screen so that their heights are the same. You adjust it so that the heights of this, heights of this, heights of this are the same. Place the screen at a distance of 110 cm from the object. That means the distance from this screen to the to this object is 110. That means the object distance plus the image distance is equal to 110 cm. That means we have gotten a formula here. UD plus VD equals to what? D, total distance. Are you getting it? So that means the object distance from here to the lens, and the image distance from the lens to the screen, all of them is 110 cm. Place the lens on holder very close to the screen and move the lens away from the screen until a sharp image of the object is observed on the screen. We also conduct that one. Are you getting it? Record the distance of the object from the lens as you. As you can see in this diagram, object is here, lens is here. The distance between them is called our U, that is object distance. And the distance of the image from the lens as V. Look at the image, look at the lens. The distance between them is called our V. You know that the sum of them will be equals to D, that is 110. Okay. With the screen and object at the same position in III, that procedure III, move the lens closer to the object until a sharp image is formed on the screen. Again, record U and V. So the first one we will do, we will get more of magnified image, and the second one we will do, we will get more of diminished image. We will see it, so to speak, as we proceed. Now, as we said, we are not going to perform this experiment. We want to see how to go about it. Rule number 1 is that note that UD plus VD equals to 110. And also note that 1 over F is equals to 1 over U plus 1 over V. That is from your lens formula. Do you understand this? Then make your UD subject of formula. It will be equal to D minus VD. D minus VD, so to speak, from what we have here. Then replace it here. You say, therefore, 1 over F equals to 1 over bracket D minus V plus 1 over V. Where VD means this V we talk about, that is image distance. Now, as you have gotten this, look for LCM. LCM of everything. LCM of this side will be equal to v bracket d minus v. So this divide this will give you v times this will give you v, plus this divide this will give you d minus v times 1 will give you d minus what? V in bracket. And so we say is equals to 1 over f. Sorting out this, we'll be having v minus v. That means 1 over f equals to v minus v will cancel out, leaving you with d all over. This times this will be vd minus v squared. That is taking you to another part now. As you can see here now, when you cross multiply, you will be getting cross multiplying this 1 times vd minus v square, you have vd minus v square equals to f times d will give you fd. Now see what you do. Take everything to one side of the equation so that this v square will be what? Positive. And so we'll be having that v square, when it come here, it become plus v square. Then this come this side will be minus vd. Then this one will remain here plus fd. Then we say is equals to 0. That means we should be solving v square minus vd plus fd using what? Quadratic formula pattern. We should solve this and see what we can get. You know that from quadratic formula, we have that ax square minus m plus bx plus c equals to 0. Af square plus bx plus c equals to 0. Where a equal to 1, then here, this is your v carrying this x. That means your v is this. And so your v is this x, so to speak. I mean to say v is x. That means minus d will be our v. B equals to minus d. Then c equals to fd. Now putting them in the formula, quadratic formula that says x equals to, instead of saying now x equals to, since x is replaced with what? V. So to speak, x is v. That is why we say b is minus d. So we will replace this with what? V. Because instead of saying x equals to, we say v equals to minus b plus or minus square root of what? B square minus 4ac all over 2a. Then what is our b? Our b is minus d. Minus times minus d is what? D. Plus or minus square root of minus d square is what? D squared minus 4ac. 4 times 1 is 1. And times this minus 4fd. All over, what is your a? 1 all over 2. That is your v. That means we have to use this formula to get our table of value, so to speak. We use v equals to d plus or minus square root of d square minus 4fd all over 2. Please, this is the formula we will use to make our table. Okay, let's see how we make this table using this formula. But don't forget about this formula. Yes, let me repeat it again. We said go to length formula. Say 1 over f equals 1 over u plus 1 over v. Then since u plus v equal to 110, because they said the distance from here to the screen is 110, it means that u plus v equal to d. That means u will be equal to d minus v. That is the implication. Then come here, replace your u with what? V, d minus v. That is from what we got here. Then look for LCM of this and this. Write them together. This divide will leave you v times 1 v. This divide will give you d minus v. D minus v times 1, d minus v. V minus v will go, leaving you with d. All over v times the vd minus v times this v square. We say 1 over f. You cross multiply. This times 1. This, they will go together, times 1. You have this. And this times this, you have this. And now rearranging them. Take everything to this side. You have here we turn to v square. Here we turn to minus v equal to f plus f equal to 0. Then next thing you do is you now solve them the way we solve quadratic formula, quadratic equation using quadratic formula. Ax square plus bx plus equals to 0. A is equal to 1, where x will now be equal to v, because that is what carrying power of 2, so to speak. And so x will be equal to v, then b will be equal to minus d, c will be equal to fd equal to 0. You write it. Then you put it inside quadratic formula, which says x equal to minus b plus or minus. Now, because our x is v, we say replace that x with v equal to this. Then we now put the values we have here inside here, taking care of our signs very well. Minus times minus this, d, plus minus d square, minus 4 times a minus 4 times c equal to minus 4 fd, because this is just c. You have this formula. That means when you use the formula d plus this all over 2, it means you are trying to get a magnified image. And when you get d minus this all over 2, you are getting a diminished image. Watch what we are saying. We are saying that we will be having two values of our image, which is the magnified one, v magnified, equals to d plus d square minus 4fd all over 2. And the diminished one, this one is for the magnified image, and this is the diminished image, equal to d minus square root of d square minus 4fd all over 2. That is, once you are able to get your v here, therefore your u will be equal to 110 minus the v you got here. Once you are able to get your v diminished, it means that the object will now be equal to 110 minus the v got here. With this formula, this, and this, we'll be able to make our table of value. Now, in this experiment, this is the table of results, or how they want your results to be what? Packaged. Yes. You will see D, that the total distance between the object and the image. You see the object distance, you see the image distance, the inverse, so to speak. Now, why do they replicate this? They replicated it because in that formula we derive, we say plus or minus. Plus is used when you want to get magnified image. Minus is used when you want to get diminished image. Whichever magnified image you get the position of the object by saying, since u plus v is equal to d. So if you get the v magnified, you say u will now be equal to d minus v what? Magnified. Are you getting it? Then same with this, u plus v equals to d. If you get your v diminished, you say the position of the object will be equal to d minus v diminished. So that is just it. That is why we say in this experiment we use formula method to run everything you want to run without wasting your time. Let's go. Our d for the first one, this will be magnified, diminished. Magnified, diminished. Are you getting it? The first one will be talking about the magnified image. Are you getting it? Then the value of the object you will write. The second, like, we follow it that way. Magnified, diminished, magnified, diminished. Okay. Our d for the first one is 110. We are doing the first one, 110 plus square root of 110 squared minus 4 times 15 times 110 all over 2. Remember that our f, we noted it to be 15 cm. Yes, that is the focal length of the lens we have in the lab of the school we are running this practical. Are you getting it? So I said if you are not able to get the focal length of the convex lens you are using in your own school, know that it ranges between 10 to 20 depending on the school, the type of lens they make use of. Are you getting it? So if they do not what give you, or you do not succeed to get the focal length of the lens you will use, just use f equal to 15. And but if you're able to get the value of focal length of the lens you are using in your school, maybe from the past set, or maybe your instructor told you guys about the focal length, you use that one, so to speak. But if you are not able to get any information about the focal length of your school, either from the past set or from your instructor whatsoever, just use f equals to 15 cm. It has a range 10 to 20 depending on school and depending on the type of convex lens, the focal length of the convex lens the school make use of. Okay, so the school I am using the lab, the focal length of the convex lens there is f equals to 15 cm. That is why we are using that one. Okay, so that is why you see, let's write it clearly so that someone can see it clearly. Our d for the first one is 110 plus square root of, our d square means 110 squared minus 4 times 15 times 1 or 110 all over 2. Okay, that means for the first one, when you press it to your calculator, you will be having it to be 92.1. You write it here, 92.10. Approximate it to one decimal place, whatever you get. When you approximate to one decimal place, just use 0 to what? Back it up. Okay? Why I say approximate it to one decimal place is because you are using measuring meter rule. You are using meter rule to do your measurement, and the reading accuracy of meter rule, because it goes by centimeter. Look at your meter rule, sample of a meter rule. If here is 0 and here is 1, there is always a tiny line, about 10 of it. 1 2 3 4 5 6 7 8 9, about 10 of it. So 1 minus 0, and this is a centimeter. 1 minus 0 is 1 all over how many tiny? 10. That gives you 0.1 cm. That means it should be in one decimal place. I just say okay, 92.1. If you write 92.1213, you are just bringing your legs out. You are just telling them you manipulated. Yes, but if you say 92.1, they will say, you performed the experiment excellently well. And so we are just attaching our words 0 to beautify our figure. We are just attaching our 0 to the answer we got to beautify our word figure. Okay, so just approximate to one decimal place and use 0 to complete it. I believe you understand what I just said. Okay, so you do that for the second one. So once you get 92.1, what will be your u? Your u will be 110, because your d is 110. 110 minus 92.1, and that will be giving you 17.9. 110 minus this will give you this. Okay, we'll come to the second 100 ohm, second magnified O for 100. We change here to 100, and we change here to 100, and we change here to 100. We also press it in our calculator. So when you press it in your calculator, you'll be getting 81.6 for this. Look at the image, 81.6. You attach 0. Then what will be your u? 100 minus 81.6. That will be giving you 18. 100 minus 81.6. That will be giving you 18.4. Do you get what we are saying? You change For the next magnified own, that is the one of 90, you change here to 90, 90, change here to 90, then change here to 90. Then you press it in your calculator and you will be having 71. 71. You write here 71.00. Then you now say 90 minus 71.00 because D minus. So 90 minus 71.00, that will be giving you 19.00. You go again. No, we say we should put it at 90. Sorry for the mistake. At 90 only is what we are discussing. So we said this is 71.00 and this is 19.00. We'll go for the one of 80. We change here to 80. We change here to 80. And we change here to 80. We press your calculator and you'll be having 60 for here. Then when you have 60 for here, 80 minus 60 will give you 20.00. We'll go for the one of 70. We change here to 70. We change here to 70. And we change here to 70. We also press it in our calculator and we'll be getting 48.20. 48.20. 70 minus 48.20, that gives you 21.80. We'll go to the one of 60. We change here to 60. We change here to 60. We change here to what? 60. Okay? We'll press in our calculator. We have here to be 30.00 and 60 minus is 30.00. That is about the magnified own. Now, to get the table of value for the diminished, change this to what? Minus. Right here 110 because the first one is 110 and here 110 and here 110. Then you press it to your calculator. The first value will now be giving you 17.90. Then you minus 110 from this, it will also give you 92.10. Then you change here to 100, change here to 100, and change here to 100. Minus, you are getting the one of diminished because we said the minus one is for diminished. You come for here, you now notice that here will be 18.40. That is opposite of what you have been getting. And minus from here, you get 81.60. We go again. We change here to 90. Change here to 90. Change here to 90. Okay? We now press it in calculator using this minus. We will be getting here 19.00 and 71.00. Wow. So, if you also do for the one of 80, here we change to 80, and here we change to what? 80. You now bring it here. You now see that here will be what? 20.00. And here will be 60.00. The reason is because 80 minus 20 will give you 60. We'll go for the one of 70. We'll write here 70, write here 70, and write here what? 70. We now say that here for the 70, here will be 21.80 and here will be 48.20. Come for this one, change here to what? 60, and change here to 60, change here to what? 60. Then when you simplify with your calculator, you have here to be 30.00 and here 30.00. With that, you are done with your table. We have formed your U and your V. For this one, they are not just serious because they are just inverse. Inverse of this U, let's get the inverse. 17.9 inverse 0.06. Let's write 0.06. I get approximately. For the one of this, it will be 0.06 because we have it at the down here. Then we also say 18.4 inverse 92.1 inverse 0.01. That is for this 0.01. Where else do we have here? 0.01. Then we now go again. That is about approximation. For 18.4 inverse 0.05. That is for this 0.05. Where else do we have it? 0.05. Then 81.6 inverse 0.01. 81.6 inverse 0.01. 0.01. We can even make it to 3 decimal places because of this is calculated value. Calculated value can be in 3 decimal places. Let's start from the beginning. 17.9 inverse 0.056. 0.056. Then 0.056. We'll have this one. Then 92.1 inverse 0.011. 0.011. 0.011. 0.011. We are putting it in 3 decimal places. Then for this one, 18.4 inverse 0.054. 0.054. Then this one 54. Then we'll go again like 81.6 inverse 0.012. 0.012. Then 19 inverse 0.052. Because we have it at the down. 71 inverse 0.014. Then 20 inverse 0.05. 60 inverse 0.0 0.017, 21.8 inverse, 0.046, 48.2 inverse, 0.021, 30 inverse, 0.033. With that, we have made our table. Yes, we have made our table. Yes, I believe we understand the concept of these formulas we drew here so that you make use of it while making your table at your own convenience. Yes, so we want to go into the questions they want us to answer after plotting our graph. First of all, we would like to know the graph they will ask us to plot and the questions that will follow through. Yes, let's see. Now, these are the questions we are meant to take care of in this experiment. And one of such questions is plot the graph of 1 over v against 1 over u, starting both axes from the origin. I must let us know that we will be having two different graphs because we got the one of magnified image and the object equivalent of it, and we got the one of diminished image distance and the object equivalent of it. So we will plot the one of inverse of the v magnified against 1 over object distance equivalent to it, and v diminished, inverse of the v diminished against the object distance equivalent to it. Yes, you will see what we mean. We will be having two different types of graph because our table demands that. Okay, in each of them, calculate the slope and y-intercept. When we get our slope, we will see what that slope will help us to get, so to speak. When we get the y-intercept, we will be able to also see what the y-intercept will help us to get, so to speak. Estimate the standard error in your slope. Yes, we will be using the two principles I discussed in one of my videos on how to get the standard error of slope. Yes, vertical scatter principle and worst fit and best fit principle. They are modulus of their difference, so to speak. We will use one of those principles and discuss that. If you want to see how to get standard error in slope, type Chidon's Daniel how to or ways, type Chidon's Daniel ways of what? Finding standard error in slope. Chidon's Daniel ways of finding standard error in slope. You will be able to see the video fully well. Yes, when you type it, you can chat me up. If you have any difficulty, chat me up. Let's see how we can sort it out, so to speak. Obtain the focal length of your lens from the graph. Obtain the focal length of your lens from the graph. We will see how to get this, and that will be coming from your slope, so to speak. It will be coming from your slope, so to speak. I will tell you how to get it from your slope. Assuming the convex lens used in the experiment is symmetric and has a radius of curvature of 25 cm, find the refractive index using the focal length gotten from the graph. We will also show you how to do that. Remember, in the course of this experiment, we'll be able to note that we have a formula we can use to get our magnified image and our diminished image and their equivalent of their object distance. We saw it. Yes. That means in convex lens experiment, the nature of their images can be what? Magnified, can be what? Diminished. Are you getting what we are saying? Yes. So we have noted that in that experiment. So we want to now see how to get the slope, the focal length, and others. From the theory of convex lens experiment, you also know that at different position you can get real image, virtual image, inverted image, upright or erect image. All these are nature of image, but this experiment showed us that we have formula we can use to get our words magnified image, diminished image. And if you perform this experiment live and direct, you will be able to see this magnified and this diminished image we talk about. Yes, and we're able to see whether you will be getting what the real and virtual, so to speak, depending on the location of your object. So we've been able to see that we can get magnified image with our shortcut method, diminish image from our shortcut method. So we want to see how to get our graph, how to do our graph, and how to answer this question. Have these questions on your mind as we sort it out. But remember that in our table of value, if we have V for magnified image to be equals to, let's say 70, and the U equivalent of it is, let's say 30, you now notice that V of the diminished image will be equals to 30 and the U of it will be equals to 70. That is, they are like opposites of it. So you can use the one of diminished image to do your plotting, and you can use the one of magnified image to do your plotting, because they are just opposite of the other. Are you getting it? They are just the same thing, just that opposite of the other in terms of V and U. Are you getting it? So either you use this magnified one or you use this diminished one, you do your plotting. And in this video, I want to use the one of diminished image, so to speak. We have the value for diminished image and the equivalent value for the object distance of it. And we have gotten their inverse value, so to speak. Okay? Now, as I always say in my videos, so to speak, if you want to do your graph plotting, first and foremost, write the date on the graph sheet. The date of the experiment on the graph sheet. That is rule number one. Then write the title of the graph. Very important. And what is the title? A graph of 1 over V. A graph of 1 over V. You attach the unit to it in per cm against 1 over U in per cm. That is your title of the graph. They have its own mark. Then label your Cartesian axis. This is 1 over V in per cm, and this is 1 over U in per cm. So now they said in that question, the question before now, they said plot the graph of 1 over V against 1 over U, starting both axes. Starting both axes from the origin. That is instruction. Yes, starting both axes from the origin. Now you notice that this didn't start from 0, 0. So for you to show that you are obeying, you are starting from the origin. What you need to do is you put zigzag here and put zigzag here. That tells you that you are obeying the rule of I'm starting from the origin. But I don't want to say 0, 0. That is what we are saying. If you check our videos on our channel, you will see a lot of discussion we have discussed on graph plotting, so to speak. Now this is about this. Then the next thing is, for this 1 over V, the least is 0.03. I can say now, let me start with 0. I can say let me start with 0.03. 0.03 to be here. That means from origin to 0.03. That is what it means. And for our 1 over U, the least is 0.01. I can say let me start with 0.01. Because I put this symbol, I'm no longer going to be writing 0, 0 again. Yes, that is it. Then, what is the maximum value for this table for 1 over v? We have the maximum to be 0.056. 0.056, yes. So what do you do for you to know what to do? You say 1, 2, 3, 4, 5, 6, 7, 8, 9. We have 9 boxes. You know, in your standard graph sheet, it is in big boxes containing 10 small boxes, so to speak. But this is just a sketch, a sketch of the graph. It's not the standard graph sheet, so to speak. And so we just want to use this sketch of graph to see what will be the range of values of what you are to get, so that when you plot your own graph, you will be able to get the actual value, so to speak. Okay, let's go. We are taking all this to be that standard wire graph sheet. That is that 1 or 2 cm, that big box. That one you have been seeing as big box. Standard graph sheet, the big box own. That is what we are taking all this to be. Okay? Okay. So you say 1, 2, 3, 4, 5, 6, 7, 8, 9. And the highest is 0.056. I will say 0.056. You know that means 0.056, I can get about 0.06, which is to 2 decimal place here. I can get 0.06 here because 0.06 is a rounded figure, rounded value of number you can get after 0.056. So let's go with 0.06 minus 0.03 divided by how many? 1, 2, 3, 4, 5, 6, 7, 8, 9. Divided by 9. That will be giving me 0.003. That will be giving me 0.003. What does this value mean? It means that the difference between this and the next value should be by what? 0.003. Now, I can decide to say, wow, I got 0.003. Let me approximate it to number that I can handle, 0.05. I just approximate it to the number I can handle very carefully. Okay, that means this I got plus 0.03. That will be giving me, when I add them, it will be giving me 0.035. That means I can come here and write 0.035, 0.040. That means it's going by 0.005, so to speak. Here will now be 0.045. Here 0.050, 0.055, 0.060, 0.065, then 0.070, so to speak. You come to this side. We have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13 buses. 13 buses. And the highest is about 0.03. That is the highest. We take it to what? I mean rounded figure, 0.04. Okay? 0.04 minus 0.01. That gives me 0.03, right? Divided by how many do we have? 13 buses. It will give you 0.0. It will give you 0.002 approximately. Are you getting it? 0.002. Now, why are we doing all this? It's for us to see what we can get. The starting point is this, and the formula is the highest point we have in our table. The highest point is this. Are you getting it? You can use this. So, okay, let's use 0.033. 0.033 minus 0.01 divided by 13. That will still give you approximately 0.002. That is what we are saying. Yes, you can also come this side and do that same thing. The highest is 0.056. Instead of using approximated value, you can use it directly. 0.056 minus 0.033. divided by 9, it will still give you 0.003 approximately. We say take the one of 0.005 because that is a rounded figure. I mean a uniform scale that can go well. Like this plus 0.005 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 this plus 0.005. Like you just be adding it and you go up. It goes by 0.005, so to speak. Then we have gotten this to be the horizontal one, and the starting point is this. You say plus 0.01. That will be giving me 0.012. So I will be having 0.012, 0.014. This, okay, 0.016, 0.018, 0.020, 0.022, 0.024, 0.028, 0.030, 0.032, 0.034. Okay, and the highest we are having is 0.033. That is the highest, so you can accommodate it now. Why we are looking for uniform scale is for us to be able to balance the vertical and the horizontal axis very well. Oh yeah, let's plot 0.011. Now, do you notice that this one is increasing while this one is decreasing, right? That means the graph will be a negative graph. I mean, it's a graph with negative slope, because as this one is increasing, the other one is decreasing. As this one is going up, the other one is going down. That means it will be a negative slope graph we will get. Oh yeah, that will give you information of what you are doing, so to speak. Now, I must tell you that before you do this plotting, try to get the mean of 1 over u and mean of 1 over v. Let's see how to get it. Add everything plus add the next one plus add the next one, add the next one, add the next one, add the next one, divided by 1, 2, 3, 4, 5, 6 into 6. We have here to be 0.018. Then we circle it. For the next one, we have 0.056 plus 0.0 plus 0.054 plus 0.052 plus 0.050 plus 0.046 plus 0.033. That will be giving you divided by 6. That will be giving you 0.049 approximately, so to speak. We also circle it. These values are called the values you will use to get your centroid. I mean the values that are to give you your centroid. These are the centroid. The value for the 1 over u and the 1 over v. Let's do the plotting. 0.011 against 0.056. Let's check. 0.011. Okay, 1 should be middle here. It should be at the center here. 0.056. Wow, 55. Are you getting it? Then 56. This is 0.055. So 0.056. 6, 7, 8, 9. So it should be about around here. We put our mark there. Then we go again. That is 0.011 against 0.056. we go again. We say 0.012 against 0.054. 54 should be somewhere here. Then we go again. 0.014 against 0.052. 0.052. That would be somewhere here. Okay. We go again. 0.017 against 0.05. 17 should be here at the middle. Okay. 0.021 against 0.046. 0.046. You now have it here. Then 0.033 against what? 0.033. This is 33. So that should be around here. Okay? Then after you have located this, the next thing you do is to locate your centroid. Why should you locate your centroid? To be able to see where your line of best fit should pass through. Yes, to be able to get where your line of best fit should pass through. Let's get our centroid. From here, 0.018 and 0.049. That should be somewhere what? Here. You circle it. That is your centroid. Yes, this is the graph, so to speak. Now, remember I said, as you want to plot this graph, don't forget to locate this your centroid. 0.018 against 0.049. You locate it. That is this one I circled. Are you getting it? Then, this one I drew this way. It is called line of best fit. Then this other one I drew like this called line of worst fit. Now remember, the intrinsic property of this line of best fit is that line of best fit must pass through the centroid. Yes, and line of worst fit must also pass through the centroid. But when you come to line of best fit, as it's passing through the centroid, if there are points that will fall out of this line of best fit, they will fall in opposite side. If it is only one point that will fall out, either of this side, it will fall out there. But if there are up to 2 points, it will fall on opposite side. If it didn't fall on opposite side, that is a wrong graph, so to speak. Then if there are 3, you can't have 3 points falling out, because 2 will fall once and 1 will fall, and that is a wrong graph. So they have to be about 4. You have to arrange it so that 4 will fall out, 2 one side, 2 the other side. Are you getting what we are saying? And so we have seen our worst fit and our best fit, line of best fit, so to speak. Now, next thing you do is get the slope of this graph and the y-intercept, or the vertical what? Intercept. Are you getting it? The y-intercept means the vertical intercept, so to speak. What do you do? How do you get the slope of this graph? First and foremost, get the slope of best fit on. Yes, you use your ruler and place it. Once you place it, you say, okay, dotted line. Then you take it horizontally. We are taking the one of best fit on. Take it horizontally. That is your best fit on. Now, you now say that means change in 1 over v or over change in 1 over u. Yes. What is the highest point here? Highest point here is about 0.557. Here is about 0.57. Trace it to that point. So we have 0.057 minus, you take the lowest one. The lowest own is about 0.035. You say here is 0.035 all over, that is the this minus this, right? Then 0.0, the horizontal part of it is 0.01 minus, watch it, this is 0.032. Are you getting it? This is 0.032 and we have 0.033 here. So it will be 0.0335, not 35. Please, that is an error from me. Let's check it again. 0.057 minus 0.035 divided by bracket 0.01 minus 0.0335. Like 0.0335. That will be giving you minus 0.9 approximately, minus 0.94. So what we got there is minus 0.94. Okay, please note that. Then we go back to the slope for line of worst fit. Now for the slope of line of worst fit, is still at what? 0.057 minus, here is 0.03. Then where it means here 0.012, that is where the vertical and horizontal meet. It gives you this 1 over u2 minus, this is 0.035. This is where I noticed that mistake for the first one and I have to redo it. Okay, we now have it to be 0.057 minus 0.03 divided by bracket 0.012 minus 0.035. We have that one to be minus 1.2. Wow, the worst fit own is minus 1.1. Okay, minus 1.2. Okay, this is 2 decimal, minus 1.17. Minus 1.17. That is the worst fit own, and this one is the best fit own. Okay. As we have noted these slopes, what will be our error in this slope? Our error in this slope, error in slope will be equals to, the one of best fit is minus 0.94, then minus the one of worst fit is minus 1.17. Are you getting it? So you have to compute it. That means minus times minus is plus. You have 1.17 minus 0.94, and the answer will be equals to 0.23. That will be the what? Error in the slope. The value for error in the slope is 0.23. It must be a positive number, so to speak. And so what do you write? You say your slope is equals to the best fit slope minus 0.94 plus or minus 0.23. No unit. No unit. Please note it very well. Minus 0.94 plus or minus 0.23. That is the slope. That means the best fit slope plus or minus the error in slope. We are using the principle of the difference, modulus of the difference between the line of best fit and the line of worst fit slope. Modulus of the difference between the line of best fit slope and line of worst fit slope. Once you get the modulus, it will be giving you positive. That is what we mean by modulus. Modulus, that is, something will go like this, modulus. Whatever you get here, whether it's positive or negative, you leave it to be a positive number. Then you attach it to the slope of line of best fit. That is the actual slope of this graph. Why are we getting the error in slope? Why we are getting the error in slope is because it's possible that what you got as your slope might not be in the range. But when you get the error you encountered while getting the slope, if they add it to that error, it might be in the range. Or if they subtract it from that, if they subtract the error from that your slope, it might be in the range. So three possible answers can be in the range. This can be in the range they have in their market script. This plus 0.23 can be in the range, and this minus 0.23 can also be in the range. One of them must be in the, at least one of them must be in the range. So that is the essence of getting the error in slope. Then the next on our list is to find our intercept. Our intercept. How do we get our intercept? Intercept means where it meets the vertical axis. For the line of best fit, the intercept there is about 0.058. About 0.05, where it meets your y-axis. Can you see it here? So for best fit intercept, for intercept of the best fit, best fit, we have it to be about 0.058. Can you see? So about 0.058 is our intercept there. Then we also say again that our worst fit, intercept of worst fit intercept is about 0.063. Look at where it is, 0.060, 0.060, so about 0.063. 0.063. Remember that we are using a sketch of graph for you to see how it will go. When you use the standard graph sheet to plot this, you will be able to get your actual values, so to speak. So this will help you or guide you to be able to choose your scale, see how to plot it excellently well. Yes. Now we have gotten our best fit intercept and worst fit intercept. So if they say find the standard error of the intercept, standard error of the intercept will be subtract these two. When you subtract it, what will you get? 0.058 minus 0.063. Whatever it gives you, when you minus these two, it will be giving you minus something. Are you getting it? Take the modulus of it, that is, take the positive answer of it. It will be giving you 0.005. Are you getting it? 0.005. That means our error in the intercept, will be this minus this, because we are using the principle of best fit slope and best fit intercept and worst fit intercept. So what will be your intercept now? The best fit intercept 0.058 plus or minus best fit intercept plus or minus the error you got, which you got by this minus this. Okay, so you have 0.005. Now this intercept will have units per cm. This intercept will have units unlike the slope. The reason is because this is the side we got it from, and the units of this is per cm, so it must have units, but the slope is not going to have any units, so to speak. Okay, that means if I get something like this, is that this 0.058 will be in the market script, or 0.058 plus 0.005, that will be giving me 0.063, or 0.058 minus 0.005, that will be giving me 0.053. So the range of the answer falls in this. That is the essence of your error. Getting your error will help you to be able to fall in the range they have. So we have gotten our slope, our intercept. Now, how can we get our focal length? How can we get our focal length? For us to get our focal length, remember that our length formula is 1 over f equals to 1 over u plus 1 over v. Taking this to the other side so that we have 1 over v subject to formula. 1 over v will be equals to minus 1 over u plus 1 over f. That means whenever you plot the graph of 1 over v against 1 over u, there is what we call theoretical slope. Theoretical slope means from formula, what nature of slope are you going to get? You are going to get minus 1 to be the slope theoretically. But practically, you might get it at minus 1 or at 0.9 or at what? Minus 1.1, depending. But theoretically, you get it at minus 1. Are you getting what we are saying? And so, from Lenz's formula, our theoretical slope should be minus 1. But from our practical, we got it to be minus 0.94. Are you getting it? So, it's still close. You can get it at minus 1.1. You see this was fit on, we have it to be minus 1.17. So this to tell you that there might be a slight difference between your theoretical slope and your experimental slope. Now, from this, even you plot the graph of 1 over v against 1 over u, the implication is that 1 over f will be your intercept. 1 over f will be your intercept. How do we know that? From our equation of straight line y equals to ms plus c, we said when you plot the graph of y against x, m will be the slope. And look at it, is equivalent to this. S is what you plotted against, plus c will be your intercept, so to speak. So our intercept represents 1 over f. So we have our intercept to be 1 over f equals to, what do we have here? 0.05 what? 8. Are you getting it? That was our intercept. Another value for our intercept is 1 over f equals to 0.058 plus 0.05. Another value for our intercept is equals to 1 over f equals to 0.058 minus 0.005. Are you getting it? So we want to see the one that will give us a good answer, so to speak. Therefore, our f will be equal to inverse of our intercept. Invert your intercept, you get your f. How do we invert? Our first intercept is equal to 0.058. Are you getting it? 0.058 inverse is equal to 17.2. 0.058 inverse is 17.2, right? So this one, our f is equal to 17.2 cm. But you remember in the starting of the video, we said f is 15 cm, right? So errors you encounter during the experiment can make you not to get the exact value. Let's check this one. 0.058. Okay. 0.058. 0.058 plus 0.005. That will be giving you 0.063. Then you get the inverse of it. What is the inverse of 0.063? That will be giving you about 15.9 cm. Then check this one so that you check the one you are to pick. 0.058 minus 0.005. You have, then invert it. It will give you 18.9 cm. From what you have here, I can deduce that finally my slope, my intercept will be equal to, I can tell them finally, conclusion, my intercept should be equal to what? This plus this is what? 0.063. Are you getting it? In conclusion, My intercept is 0.063 because that is the one that is okay. But in exam, you just write it like this. They are the one to pick what they want. Are you getting it? And I'll just say, in conclusion, I is 0.063 from what I have, and the focal length of it is equal to 15.9 cm. This is per centimeter, and this one is in cm. So I've told you guys that getting plus or minus tells you that either it is 0.058 or plus this or minus this. That will be your intercept. Same with your slope. But it is good you package it like this. This is a comprehensive way of packaging it. Are you get what we are saying? Then why writing your intercept? Because of what you just check out in your rough work, and you check out this, you realize that you say, my intercept, I take my intercept to be equal to this plus this, that is 0.063, and focal length to be 15.9 cm. You understand? Because that is the value that will get close to it. It is meant for the examiner to use what you have here to what judge you. Even if you write 0.058, even if you write my focal length is equal to 17.2 cm and my intercept is 0.058, as it is like this, even if you leave it like this and say focal length is 17.2 cm, it is not wrong. You are very correct. It is them that will what? Check, wow, you attach your error. And when they now check your error encountered with your results, they will be able to see that you also have this as your answer. Are you getting what we are saying? So we have said in essence that slope is this, attach the error encountered. Intercept is this, and also attach the error encountered. They are very important. Okay? Then you can only use this intercept to get your what? Focal length by getting inverse of 0.058. It is 17.2 cm. Someone can say that what it has here is 0.059. If it says it is 0.059 that you have, 0.059 inverse, you still have it at 16.9 cm. Are you getting it? Because this is either 0.058 or 0.059, depending on if you are using standard graph sheet. Are you getting it? So if we are putting here as 0.059, because what we have here is close to 0.060, it means that here will be 0.059. Are you getting it? Then 0.059, if you subtract them now, it will be giving you 0.004. So here will now be equal to 0.004. So if you write the first one we just wrote, you are correct. If you also write this one, you are also correct. Are you getting what we are saying? Then this one will now be 0.059 plus this. Then this one will be 0.059 plus this. Are you getting it? And so what you'll be having in essence is that 0.059 will be given 0.059 inverse to get your focal length. It will be equal to 16.9. You write here 16.9. 16.9 cm. That is about that. Okay? That is about it, so to speak. Then when you add, it will be giving you 6.3. So the same thing will be 15.9 cm. Then when you subtract 0.055 inverse, it will be giving you 18.2 cm. That means these are possible value of your focal length you can get, and one of it must satisfy the marking script they have. So I guess the one that will satisfy it very well is this one. And so that is the essence of you getting your error in your slope, getting your error in your intercept. It helps you to be on a safe side. Because if you just write intercept is zero without the error being attached, if this you got is not in the option or is not in their range of value, you have failed it. But if you attach your error encountered, you will get it, because when they add, they will check whether it's in the option, or when they subtract, they will check whether it's what in the option. Because they say standard error in your slope and your intercept. Once you write this, you attach by this side SE. And once you write this, you attach SE, because we are talking about the standard error of it. SE. Very important. And so we have seen our possible value of slope is this, seconded by this plus this, and next this minus this, 1. Another value for our intercept is this plus or minus this, or this plus this minus this, or only this. Either only this, or this plus this, or this minus this. Or even the first one we wrote, 0.058 plus or minus 0.05. 0.058 minus 0.005. 0.058 plus 0.005. That first one we wrote, and this one, they are just depending on what you got here. So you take your time, use your standard graph sheet and replot this, so that you'll be able to get your exact value. Because why you are seeing us getting 15.9 instead of only 15 cm, getting this range of value means 1 fall inside the marking scale, that 15 points. Are you getting it? That why we are getting this is because we use a sketch of graph to do the plotting. That is 1. And 2, the small errors encountered is what made us not to get only 15 cm. So we are getting 15 points, 16 points. So 1 satisfy the question. Okay, so we have gotten our focal length of the graph. Assuming the convex length loose in the experiment is symmetric and has radius of curvature 25 cm, find its refractive index. They say radius of curvature is 25 cm. Find its refractive index using the focal length gotten from the graph. And we are using the focal length that says 15.9 cm. Because from what we have one that gives us F equals to 15.9 cm. Okay, then we said when the convex length is symmetric, it means that the focal length is equal to R all over 2 bracket refractive index minus 1. Please don't forget about this formula. And with that, now we make our refractive index subject of formula. Our F is 15.9 equals to 25 all over 2 bracket n minus 1. Keep n minus 1 here. Keep this refractive index here. 2 times 15.9. 15.9 times 2 gives you 31.8. 31.8 equals to 25 all over this minus 1. Take refractive index minus 1 up, take this down. You have this minus 1 equals to 25 over 31.8. 25 divided by 31.8. That gives you 0.79 approximately. So this minus 1. So refractive index is equal to, this goes here, 0.71, 0.79 plus 1 will give you 1.79. So that is the value for refractive index of that convex length. It is equally important to get the error in the focal length gotten. If you're able to get the error in the focal length gotten, it will even take care of this 15.9 you got. Yes, let's see what I mean. We have that focal length is equals to inverse of intercept. Are you getting it? Therefore, You say to get the error in this, standard error in focal length all over focal length equals to you now say here is -1 times error in your what? Standard error in intercept all over intercept. You square it. Okay. The power of this is -1. Make it to be 1 so that you will not square anything. 1 times standard error in intercept all over this. Therefore, standard error in intercept will be equal to focal length times what? 1 times standard error in intercept divided by what? I. Yes, if you want to get your focal length, the error in it, because it's important. They may not be asking you to get this, but you have to solve everything so that whichever one they want, they will take it. Watch. Focal length is 15.9. That is the one we decided to take. You understand? 15.9. So if you do not want to use 15.9, you can use the first one. I get it, but we decided to use 15.9 because that is quite accurate. Times 1 times what is standard error of intercept? 0.04. All over what is the intercept? The intercept is 0.059. Are you getting it? So we now have it. This is 0.059. But this 0.059 we wrote here, the 0.059 we wrote here is coming from what we have here. But what did we use to get our 15.9? We use the one of 0.059 plus 0.004. And so instead of you writing 0.059, because that is not what you use to get your 15.9, you write the one of 0.063, because this is what we use to get our 15.9. Like we say 0.063 inverse is 15.9. So this is what we use. This is the intercept we use to get our focal length, and this is the error. Please watch it very well. Then you would write 15.9 times 1 times 0.04 divided by 0.063. That will be giving us that the standard error in F So that is how to conduct this experiment without touching apparatus. Remember, as you finish plotting your graph, don't forget to write your scale. Are you getting it? Don't forget, it is very, very important. 2 cm represent, what do we have here? This minus this, 0.005 per centimeter on the what? 1 over v axis. Then for horizontal on 2 cm represent 0.002 per centimeter on 1 over u axis. Okay, so we have 2 cm representing 0.005 per centimeter or 1 over v axis, and for this one 2 cm represents 0.02 per centimeter on, because we said each of these balls is taken to be that big balls we are seeing in standard what graph sheet. Okay, so note that very well. Then do not forget to include your precautions. Yes, we have so many precautions. You at least put about 2 precautions you noted or took care of while doing this experiment. You know there are many. You use measuring ruler, you use meter rule to do your what measurement. You can start by saying error due to what parallels was avoided while taking my words reading from the meter rule by placing my eye vertically downwards on the meter rule. So you would say the error you avoided and how you avoided that error. 0 error was also avoided while taking my reading from the meter rule by ensuring that my reading starts from 0 by ensuring that my reading start from zero. Are you getting it? So ensure you give at least 2 precautions at the end of your experiment. So if you find the video very helpful, don't forget to click subscribe, like the video, share to your friends, comment on your difficulty. We'll be uploading more practicals on physics. Don't forget to continue keeping in touch with our channel because you must learn a lot and a lot. See you in the next practical.